Hi, let's take a look at how to handle piecewise functions. Some people find them kind of confusing, maybe even intimidating, but hopefully with a few simpler situations we can get an idea of how to handle them without finding them so overwhelming. So let's look at a simpler situation first. Let's say I'm working at a pizza shop and we have a few rules that dictate how many pizzas we make per hour. And those rules have to do with what time it is. So for instance, I'm going to say that if the time is between 1 o'clock and 4:59, then we're going to make 5 pizzas per hour. If the time is between 5 o'clock and 10 o'clock, we make 20 pizzas per hour. Now this is a very real situation. A shop wouldn't want to make more pizzas than necessary, but when, say, the dinner rush hits, they have to increase the amount of pizzas that they make. So for instance, if I gave you the time of 2 o'clock, I could look at these rules and say, well, that's in this first situation. 2 o'clock is between 1 o'clock and 4:59, so we're making 5 pizzas per hour. So the output of that shop is 5 pizzas per hour. If I gave you the input time of 6 o'clock, that would be in this second situation. That means we're making 20 pizzas per hour. If it was 5 o'clock, that would also fall into the second situation, so we're making 20 pizzas per hour. This is a piecewise function. I'm giving you an input of a time. There's an output here. And for each input, there's a unique output. So it's a function, and there's multiple parts, so it really is a piecewise function. We have a rule that decides where that input is going to take place. Now let's take a look at how this would work with notation. So let's call up one of our good old friends, the function f. Everybody seems to like it. It's very popular. But today, f is going to have kind of a split personality. So I'm going to use this brace right here to kind of gather up all of its personalities. And the first part of it is for input values. We're going to use x for our input variable that are, well, let's go with the same thing we had for the pizza. Starting at 1, so greater than or equal to 1, up until 5, so less than or equal to 5. And the next part will start at 5 and then continues on and includes the value of 10. What are the outputs? Well, this followed the same thing again from the pizza situation, where we had 5 pizzas per hour between 1 o'clock up until 5 o'clock, not including 5 o'clock, stopped at 4:59, and then 20 pizzas per hour from 5 o'clock until 10 o'clock. And again, we can look at this. So let's say our function was given the value of 2. Well, 2 is between 1 and 5. So the output is listed right here, would be 5. F of 6, that's going to fall into the second situation. It's between 5 and 10. And its output would be 20. F of 5, sorry, writing things backwards there. Well, which one does this fall into? It'd have to fall into the second one because the first rule states that it's specifically less than 5. The second one can include 5. So the output there is 20 as well. Well, that's all good and dandy, but we very rarely have these constant outputs for our math problems and our homework and whatnot. So let's look at a situation that might be a little bit more involved. Let's call up our function g. And let's give g some rules for the inputs. We'll again have 2 of them. We could have as many as we want, but just for simplicity's sake, let's just go with 2 of them. So let's say x is greater than 1, less than or equal to 7. And here let's have it start at 7 again and go up until 10. Then our rules will be 2x for the first situation and x plus 1 down below. So g of 4, putting 4 in, that would fall in the first situation because that's between 1 and 7. That would mean I'd have 2 times 4. So g of 4 is 8. G of 9, well, that's not between 1 and 7. That is between 7 and 10. So g of 9 would follow the rule of 9 plus 1, the second one here. So that gives me an output of 10. There we go. There we're working. I hope that helps to clear things up a little bit or give you a nice introduction to piecewise functions. We'll tackle graphing them a little bit later. Thank you.